All right, so eventually we're going to calculate integrals by hand. A lot of integrals by hand, though not as many as a traditional calculus class might. And even the best mathematicians in the world cannot calculate every integral by hand. And we'll do that with like formulas. Just like we had those derivative formulas, we'll also have antiderivative formulas, integral formulas. And yes, antiderivatives are a thing. We're also going to use technology. We will have a time to do them by hand, but in this section, we're just going to do it with technology. So to do an integral like this, essentially all you do on Desmos, and you saw it before and I said I'd show you later, is you just type int, int for integral. There's probably something, and then you just type everything else in like you would expect. There was probably a button somewhere down here. You go under calculus. Yeah, there's a button down here as well if you want to use that button, but it's much quicker for me to just write I, N, and as soon as you write the letter T, transforms into an integral. And then you can fill it in as you want. So let's show this off right here with our first example. I can't find, there we are. So approximate this integral with technology. We've already drawn a picture of this integral way back when. We've already drawn this picture. We know that this blue area is this integral. Now, let's actually find, sorry, my cat is, October's doing weird things around my feet. Now we're going to actually find this integral. So, the integral from 1 to 5 of 1 over x dx. We typed in int, put a 1 here, again press tab or use an arrow key. Go 5 here, press tab or use an arrow key. What's our function? 1 over x. Again, you can be clicking all of this down here if you'd like as well. Press tab. It's not giving us an answer yet because it doesn't know what our variable is. Write d x. And there's an approximation of the integral. It's about 1.609. That's the answer. I did tell you it had something to do with natural logs. Check this out. But I'll show you where that comes from later. That's a future section, but kind of cool. All right, so that's what that area is. It's about 1.609. Let's do another example. This is a longer example. The graph of this function, y equals x squared minus 5, that's a parabola, is shown below. So part A wants you to draw on this graph to visualize the integral from 0 to 2 of this function with respect to x. So remember, indefinite integrals are signed area. So between 0 and 2, that's between x equals 0 and x equals 2. So it's going to be the signed area of this region, like so. So it doesn't go all the way to the side, but it's going to be this area, and its signed area. Is it going to be positive or negative? Notice we're below the x-axis here. It's going to be negative. So letter B says, how do we know that each of these are wrong? So I have 3 different claims. And why is this in the technology section? Because when you're using technology, you're just getting the answer. You're not seeing the process, so it's much harder to tell whether you've made a mistake. So being able to know kind of what you should expect is really helpful. So if we know this is what the function looks like and we use technology to find it, and let's say Desmos told us this area was 5. where this integral is 5, we would know we messed something up. This integral cannot be 5 because we're below the x-axis. So we know this integral should be negative. So just being aware of some of these things is going to make it a lot easier for you to use technology effectively, to have an idea of what you should be expecting. Now the second one looks more believable. It's this negative number. This negative number is too big. How do we know that? How do we know this integral should not be negative 10? This integral should be some negative number, but not that negative. How can we know that's wrong? Well, negative 10, that's 2 times 5. What is that area? What is this blue area? Well, that's a rectangle of width 2 and a height of 5. So we know that this could be an approximation, not a good approximation, but this is an approximation of that integral. But we do know that it's not the right answer. If we use technology, we know this might be an approximation, but it's not a good one and it's not exact. Okay. So specifically, we should expect a negative number, but not quite negative 10. Single digits, probably. Because blue is too big. All right, this is too big of a negative. And similarly, number 3 is too small. How can we know that? How can we visualize negative 4 as an area? Well, negative 4, you could think of negative 4 as this blue area. And yeah, we're overcounting a little bit right here. But we're undercounting a heck of a lot. We're not counting all this area. You know that blue couldn't be right. Or you could think of negative 4 as this area. 1/2 base times height. Well, we know that the integral is that negative signed area is the red area. This blue number of negative 4 is too small. Okay. There are lots of different ways of recognizing this, but it's usually a good idea when you're doing integrals with a calculator to just make sure that the answer seems believable. Okay. So this is too small. And there's a couple of ways that you could see it's too small. So letter C, let's actually find out what it is using Desmos. Integral from 0 to 2 of x squared minus 5. Integral from 0 to 2 of x squared minus 5. Let's use parentheses. Dx should be about negative 7.3. That's what it is. Also, little fun fact. This one's a little bit weirder to see where it comes from, but maybe. This is the end of the video, by the way. This is the end of the video. You don't have to pay attention anymore. But if you want to see where this comes from, using future techniques, it's going to be 1/3 of 2 cubed minus 5 times 2. And that's accurate. But really what's happening is we're subtracting out 1/3 times 0 cubed minus 5 times 0. Any ideas on where this comes from? That's where we're going in the future. This is quite a bit in the future, but eventually we'll learn how to calculate this by hand. Essentially, what's happening is we're looking at the antiderivative, undoing a derivative. In other words, the derivative of what quantity is x squared minus 5? Then we plug in the limits of integration and subtract them. But again, that's the future. Let me know if you have any questions, and that's it for this video.